Hi, everybody, and welcome to Unit 3. Unit 3 is a great unit. We start dealing with actually writing out chemical formulas and being able to name compounds here. Let's just talk a little bit about the background. Atoms combine with each other to form compounds. They do this to become more stable. Remember, they really want to be like those noble gases. They want to have that full octet of electrons. And one way for them to do that is to combine with other elements. There's three ways that they can combine. All right. And if you want to pause here to jot this down, you certainly can. All right. So 3 types of chemical bonds. The first is ionic. You know you're dealing with an ionic bond, an ionic compound, because you're dealing with a metal and a non-metal. In this case, electrons are gained and lost. All right. Metals lose electrons, non-metals gain them. The second type of chemical bond is a covalent bond. This is where electrons are shared, and this typically occurs between 2 or more non-metals. The final one, which we're really not going to spend a lot of time on right now, is what's known as a metallic bond, and this is the bond that holds one metal to another. All right, so what we're going to cover now is review from Unit 2, all right, but hopefully you are still... which hopefully you still know, but we want to make sure you get down, okay? Remember, when looking at your periodic table, you have a stair step. Everything to the left of that stair step is a metal. Everything to the right is a non-metal. That's going to become really, really important to us in this unit when we're figuring out what type of compound we're dealing with. All right. Groups 1, 2, aluminum, and I should have typed in here zinc and silver, are considered our regular metals, okay? Groups 3 through 12 are D block, or what are known as transition metals. You then also have some metals that are not part of the D block, but are under these stairs here. All right, some things like lead. These are what are known as heavy metals, but they are treated for naming purposes as transition. So when it comes to metals, you have your regular metals, group 1, 2, aluminum, zinc, and silver, and all other metals we're going to treat as transition metals. Okay, so we're going to focus today on ionic compounds. Ionic compounds are formed when atoms gain and lose electrons. We know this from our last unit, that a positive ion is known as a cation. All right, and this is just the example. What happens with sodium? It has that single electron in its outer shell, so it's going to lose that electron. All right, once it does, it only has 10 electrons and 11 protons. I know I'm going through this quickly, but you already had this. So therefore, sodium gets a +1 charge. We know that oxidation numbers are periodic properties. Therefore, we can look at the periodic table, all right, to tell us what the charges are. Okay, because elements within the same group have the same number of valence electrons, they're going to have the same charge. So group 1 is +1, group 2 is +2. Again, aluminum is +3, zinc, I should have written in here, is +2, and silver is +1. For our negative ions, group 17 is -1, group 16 is -2, and above the stair step, nitrogen's group is -3. Below the stair step, it becomes a metal, and metals are always positive. Okay, that's another thing to really remember. When forming ions, metals will always form positive ions, non-metals, negative ions. Okay, great. All right, so as we had up here, a positive ion is when an electron has been lost. Well, that electron, you guys asked me this last unit, it's a great question. Well, where does it go? Well, it goes to another atom and forms an anion, a negative ion. All right, your non-metals, they want to gain electrons so they can be more like noble gases. All right, so something like sulfur, okay, needs 2 electrons to become like a noble gas, so it will gain those from a metal and then have the charge of -2. All right, okay, great. We're going to now go on ahead and actually start naming those compounds. All right, anytime we use the word compound, we know that that substance is neutral. And what I mean by neutral is electrically neutral. So the charges must always add up to 0. All right, so let's talk about what that means. Let's say I have a calcium ion, all right, and it's going to form a bond with some iodide ions. Now, remember, you should always have your periodic table out. Calcium, as we know, is group 2, so it's +2. Iodine is in group 17, so that makes it -1. All right, so if these two were to get together, all right, and I had one calcium and one iodide, those charges are not going to add up to 0. They'd add up to +1. So what that means is that you're going to need 2 iodide ions for every 1 calcium. Then the compound would be written like this: CaI2. I have 2 iodines, I have 1 calcium. Now that's 2 negative total, 2 positive total, that equals 0. That is a proper ionic compound. All right, so let's talk about naming and formula writing for ionic compounds. All right, there are a couple different types of ionic compounds. The first we're going to talk about is what's known as binary. So that means it has 2 elements in it. All right, with regular metals. Now remember, regular metals are groups 1, 2, aluminum, zinc, and silver. We always know the charges of those, all right? So that's why we refer to them as your regular metals. So let's look at an example. Let's say I give you the name magnesium oxide. All right, great. So your job is to write the formula. Well, magnesium, all right, I have my periodic table. It's in group 2. So that means that it is +2. So I have Mg, 2+. Oxygen is over here in group 16. Group 16 is -2. All right, so that's O2-. All right, well, magnesium's 2+, oxygen's 2-. So when I add up 2+ and 2-, that gives me 0. So I just need 1 of each, MgO. All right, there should never be charges written when you write a neutral compound. Okay, if we're going in, actually, let me give you another example here. Let's go on ahead and write the formula, please, for aluminum sulfide. All right, so for aluminum sulfide, aluminum is +3. Sulfur's in group 16, so it's -2. All right, so I have +3 and -2. With these, you have to think, what is the least common multiple? What's the least common multiple of 3 and 2? It's 6. So how many 3s am I going to need to get to +6? I need 2. So it's going to be Al2. How many -2s do I need to get to -6? I need 3 of them. So S3. Okay, as far as naming, you might have already been able to tell from the name. The only change is for the negative ion, if you notice, we don't write magnesium oxygen, it's magnesium oxide. So we change the ending of the anion, the negative ion, to IDE. So if I were to give you this formula, BaF2, all right, you're just gonna write the name of the metal, barium, and then this is fluorine, but we're not going to write fluorine. We're going to write fluoride. Okay? All right, fantastic. Our next type of ionic compound are still binary ionic compounds. All right, so still just 2 types of elements in it, but now with a transition metal. So transition metals are all of the other metals on the periodic table, and remember, metals are to the left of this stair step. So all of these other metals that are not group 1, group 2, aluminum, zinc, or silver. So if I'm not 1, 2, aluminum, zinc, or silver, I am a transition metal. Really important. Transition metals have charges that can change. All right, so except, as we talked about, zinc and silver, we know those, so those are regular. All right, because the charges of transition metals can change, we have to, in the name, tell the reader what the charge is. So for example, all right, copper 2 chloride. We use a Roman numeral to tell us the charge. Again, the Roman numeral is the charge of the transition metal. It's not how many there are. All right, so copper 2 means that it's +2. All metals will always be positive and positive ions. All right, so copper is +2. Chloride, we know the charge of, that's -1 because it's in group 17. All right, so if we're going to write the formula for this, I need 2 chlorides for every 1 copper, so CuCl2. All right, okay. Feel free to pause the video here if you'd like to give these 3 a try. Okay. All right, so manganese 3 bromide. Manganese then is +3 because of the Roman numeral 3. Bromide's group 17, so it's -1. So what is this going to be? MnBr3. All right, so iron 1 oxide. That means iron is +1. Oxygen we know is -2. So I need 2 irons for every 1 oxygen. So Fe2O. All right, well, when you're working in the other direction, going from formula to name, this is where things get a little harder. So if I were to see this and know I need to name it, I'm going to ask myself, okay, scandium, is it a metal or a non-metal? All right, it's to the left of the stair step. It is a metal. Is it regular or is it transition? Well, it's not in group 1. It's not in group 2. All right, it's not aluminum, zinc, or silver, so that means it's transition. I need to figure out what the charge of that scandium is. Well, I'm going to use the charge of the negative ion to figure that out. Sulfur's -2. There's only 1 sulfur. So that means you have to balance out a -2 charge. Well, there's 2 scandiums, so the overall positive charge must be +2, but there's 2 scandiums. So what's the charge on each of these? It's +1, because +1 times 2 gives you +2, and that's how we make this compound neutral. So the name is going to be scandium 1 sulfide. Okay. All right, I have about 16 practice problems for you in your sheet. I would like you to pause the video now and go on ahead and do those practice problems. All right, everybody, so let's take a look at the answers for these. And I'm just going to point out a couple of places that you may have made mistakes. First, pause and check your answers. All right. Some things to note. All right. When you're writing a symbol from the periodic table, such as barium, it is always capital B, lowercase a. All right. Never, never, never capital B, capital A. The first letter is capitalized. Then if there is a second letter in the element, it is lowercase. All right. That's really important. And you don't ever want to make that mistake. Other things as far as formula and name writing, please make sure that you only have Roman numerals, okay, as far as your name. You should only have a Roman numeral here on number 13 because that was the only one when it came to naming that was a transition metal. All right, otherwise things like barium, lithium, okay, sodium, aluminum, magnesium, calcium, lithium, and zinc, all of those are regular metals. Note also that Roman numerals are always in the name. They are never in the formula, okay? All right, so we're gonna move on to actually technically part 2 of your notes, but we're gonna do them all together because they still have to do with ionic naming. All right, so our third type of ionic compound is what's known as a ternary ionic compound. And ternary means that you're gonna have 3 or more elements present. All right. All of these ternary ionic compounds have what are known as polyatomic ions. Before this, all we were talking about were things like sodium ion or chloride ion, and those are all called monatomic ions. Okay. So, all right. Okay, so single ions are monatomic. Polyatomic ions are actually atoms that are covalently bonded, great, but still have an overall charge. Now, where are you going to find them? On the back of your periodic table, you have the oxidation numbers of common polyatomic ions, all right? become very familiar with these. You're not going to be memorizing them because you're always going to have the this on the back of your periodic table. But it's really important that when you read the name, all right, that you are very familiar with it, okay? So I would read over these several times. So for example, if you hear thiocyanate, you're not going to think that that's an element that you should find on the periodic table. You'll know to look at the polyatomic ion chart, all right? So let's see how we're gonna use this. One of the big things, and I have this bolded and starred here, do not change the name of a polyatomic ion. You're gonna write it exactly as it is on the back of your sheet. If you need more than one polyatomic ion, you're gonna use parentheses and a subscript. Let's see what I'm talking about, all right? So calcium hydroxide, all right? Well, calcium, we know what calcium is. Calcium is Ca2+, great. Hydroxide, please don't think that that's some sort of strange form of hydrogen. It's not, all right? It is a polyatomic ion. And again, you're gonna become familiar with these. You'll see hydroxides here. It's OH with a -1 charge. That's what hydroxide is. All right, well, still compounds have to be neutral. So what we need to do is need to say to ourselves, all right, well, calcium's 2+, hydroxide's -1. So I actually need 2 hydroxides to go with that 1 calcium. I'm gonna write this Ca, and then I put parentheses around it, around the hydroxide, because I want 2 of them, okay? As opposed to if I had written CaOH2, that would just tell me that I have 2 hydrogens, all right? I need 2 of the hydroxides. So that would be wrong. This is what we're going for. Okay. All right, so let's take a look at a couple more examples from your notes. All right, great. So here we go. I have Na3PO4, so this means I need to write the name for it. Well, Na is sodium, we know that. I see automatically that there are more than 2 elements here, so I'm gonna look on my polyatomic ion sheet and find PO4. All right, PO4 is here under the -3. It is called phosphate. All right, I do not change the name of a polyatomic ion. Sodium is a regular metal, so it's just gonna be sodium phosphate. All right, no Roman numeral because we know the charge of sodium, so sodium phosphate. Okay, all right, copper 2 sulfate. Well, copper 2, remember, means that the copper has a charge of +2. Sulfate, let's find out what that is. I look on my polyatomic ion chart, it's right here. It's SO4 with a -2 charge, so it is a -2. All right, so I'm just gonna go ahead and write that, CuSO4. You only need 1 sulfate. We don't use parentheses when you only need a single polyatomic ion. So this would be how we'd write that formula. All right, here we go. Our last example, this manganese. Again, I'm gonna go through the whole routine. Manganese, is it a metal or a non-metal? Well, it's a metal. All right, it's to the left of the stair step. Is it in group 1, group 2, aluminum, zinc, or silver? No, it's right here. Manganese is there, which means it's a transition metal, which means it's my job to figure out what the charge is. Well, to figure out the charge, I need to look at my polyatomic ion. My polyatomic ion is nitrate, all right, is NO3. I look at my sheet, I find NO3 is right here, it is nitrate. It has a -1 charge, all right, so nitrate has a -1 charge. There are 2 nitrates, which means I have an overall -2 charge I have to deal with. I only have a single manganese, which means that that manganese has to balance out that charge, so it's gonna be +2, all right? So here's my name, manganese, Roman numeral 2, because that's the charge, all right? So this becomes the Roman numeral 2. And then I just write the word nitrate. All right, fantastic. We're gonna do a lot of practice with this in class. Thank you.